Today, 1-5, it's factored by grouping. So we're going to start off with a little bit of different way the problem's set up. Notice we have 4 terms. So far, we've been mostly dealing with 3 terms. The exception was when it's like a greatest common factor and you just take out the terms. But the factoring the trinomials, 3 terms, and we had our processes for that. With that idea, factor by grouping, the steps that we do here is going to show up when we have 4 terms. Now, if we took this and tried to force feed it into what we've already done, and let's say I drew the box and tried to solve it, we'd have some issues. Let me move that. So first off, I could go like, well, maybe 36 goes here, 2m to the third there. But that diagonal wouldn't necessarily be, wouldn't necessarily work, because we're not going to have like terms there. Maybe I want to put like an 8m squared and a 9m. And we start to get some ideas on where things fit, and you can piece it together. Now, worst case scenario, it's a guess and check from that. And maybe we switch the 8m squared to the 9m. We have a little bit easier break here. Whenever we have factor by grouping, we're going to kind of reverse distributive property a couple times. And it's a different way than we've seen distributive property before. So I'm going to put the box aside, and let's just focus on these 4 terms. So factor by grouping 4 terms. I'm going to factor the first 2 terms together, the last 2 terms together. Now, they will have a common factor. Well, at least one of them will have a common factor. If not, we would factor out a 1. But in this case, it works for us. What could I factor out of 2m cubed and 8m squared? Okay, so that comes out. I'm left with m plus 4. Okay? How about 9m plus 36? What can you take out of that? Okay, 9 comes out. Plus 4. All right. What do you notice?
You have 2 answers.
I have m plus 4 and m plus 4, right? Now, it's not factored because it's addition still between the 2. But each term here has an m plus 4, right?
Yeah.
So I could take out that term from both of them. Factor it out. It comes out. If it came out of this term, I'm left with a 2m squared. If it came out of this term, I'm left with a 9. And what we suddenly stumble across is m plus 4, 2m squared plus 9, which is the factored form of what we started with. So we basically factor 2 times, or 3 times. We factor out of the first 2. We factor out the last 2. This will be in common, m plus 4. It won't always be m plus 4, but these will be the same. If they're not, you didn't do it right, or it doesn't factor. Then you factor with that common link out and write the leftovers. 2m squared plus 9. Now, let's go back over to the box. We said it didn't work. Let's see if actually things would have fit. So if I would have put 2m squared there, plus 9, and m plus 4 there, would that have worked? Okay, it would have worked. It also lets us double check that by putting those there, this would have still gotten back to our original answer. So multiplying it back together, it would have worked. Again, 4 terms, we're going to factor by grouping. Factor out of the first 2, factor out of the last 2. They'll have something in common. Factor that out. Let's do the process again.
What if they don't have something in common?
You either didn't factor it correctly or it's not factorable. Yeah.
How come it wouldn't be m plus 4 squared if it's regular?
If I thought of this as let's not think of it as m plus 4. Let's just think of it as a blob. Okay? It's a variable. It's a value. It's just there. Now, both of these terms have it there. So I factored out. It's almost like if it was 2m squared n and 9n. It's just another value. If I factor out the blob, I factored it out of both terms, so it's left with what we have. It's not that we have two of them. It was just something that we could factor out. Good old blob. It's the best variable we got. All right, let's do. Just don't square a blob. So, first two, what comes out?
3.
3x squared? Oh, that should be an x. Hold on. All right, why do we have m and x? Because why did I start writing down? I don't know. Should be x's, okay? 3x squared comes out. What's left after we factor that out of the first two terms? Okay. Now we look at 2x plus 3. Does that factor anything?
Wait, why would it be 2x3? Oh, okay, never mind.
Okay, last two. 2x plus 3. Is there anything we can factor out of it? No. But let's say we did factor out a 1. It's multiplying by 1. We can factor out a 1. There's 2x plus 3 left. That's actually a good thing we can't factor anything, because do we have matching terms? Yeah, like the blobs. We have matching blobs here. So now 2x plus 3 comes out of each term. And what are you left with? 3x squared plus 1. So you got to have the 1, because if I factor this out, it doesn't become 0. It has a 1. These will end up as a binomial times a binomial. 2 term times 2 terms. Starts with 4, ends up with 2 and 2. Okay, are you following the process?
Yeah.
Okay, let's try those two. I'm not worried about what exponents I have, how large the powers are. Focus on the first two, last two, factor them, get something in common, then factor that out to get to your result. Okay, let's check to make sure I see a common error occurring with these signs being off. Let's check to make sure we understand this. 64d cubed minus 40d squared looks like an 8d squared. Okay, leaves us with 8d minus 5. Okay, now, in the last two, I can factor out a 3, but see how that's negative? I'm going to factor out a negative 3. So that makes this 8d, which is good. That's really what we're looking for. We're like, all right, I already got 8d minus 5 over here on the left. I want to get it to be the same. I got to take out a negative 3. In doing that, what does that make this? That makes that negative 5. The negative changes both signs. So if you're ever doing this and you're like, well, wait, they're opposite signs of each other, take out a negative. Okay, take out that negative. So now I got 8d minus 5 was the common term. 8d squared minus 3 was the leftovers. Okay, some of you put parentheses around this 24d, and kind of ignored that negative. Got to be careful about that. Think of all the two terms. All right, come down here. We can take out an x to the 4th. So we got 3x squared plus 5. What do you want to take out for the next set? A negative 1. You see that again, negative 1. 3x squared plus 5 changes both signs. They match. Don't be like, yeah, they match except for that one sign being off. You got to make sure they do match. So I got 3x squared plus 5 and x to the 4th minus 1. And then we do our best late night infomercial impression and say, but wait, there's more. Did you stop at x to the 4th minus 1? Oh, difference of 2 squares again. 3x squared plus 5 stays, but x to the 4th minus 1 becomes x squared plus 1 and x squared minus 1. But wait, there's more. This one's still difference of 2 squares. This one factors to then be x plus 1 and x minus 1. So we snuck difference of 2 squares into it.
That's not fun. That's like, hey, why do you want to kill us?
Really? This is what brings you to the breaking point?
No.
Okay, let's make sure.
Last year we got me to the breaking point. It was just really confusing. Stop.
Okay, so again, 3x squared plus 5 was good. That's going to stay here. X to the 4th minus 1 is a difference of 2 squares. We have squares, it's subtraction. I break it into these two. X to the 4th becomes an x squared, and an x squared we have the different signs. That's done. X squared plus 1, it's not a difference of 2 squares, it's not subtraction, so that just stays as it is. This one, though, it keeps going. So that is still a square minus a square, so that's how we got to the x minus 1, x plus 1. This is how we bring in that extra factoring. Now, realize you'll have some straightforward factoring ones, but as we start to put it all together, I would expect like a difference, factored by grouping, to have something like this snuck in where you have to keep going. It's paying attention to the factors. Now, that's probably as scary as we can make it. If I wanted to add another layer to it, maybe I would have a common factor you could pull out of all of these. Maybe it started as like 30, 50, 30, and 50, and then you take out a number to start. But it's still there. Whenever I see 4 terms, I would go factor by grouping. That's where we start to look first. 3 terms, trinomial, you can take care of that. 2 terms, you may be looking at difference of squares. 4 terms, we think factor by grouping. So that's the straightforward approach. We good with that so far?
Yeah.
Okay. Now, we're going to take what we did on Tuesday and apply it to factor by grouping.
What?
So, this is factoring ax squared plus bx plus c, or when there's a coefficient, with grouping. Okay, this is an alternative to the factoring with the box method. This is an alternative to factoring by Berry method. It's just another option. If you're still kind of like, I see what's going on with that factoring, I'm not sure, but factor by grouping works. I just want to show you this approach so you see it. You have the option. We then have, I think we're testing a week from today. You got a week to figure out what's your best approach. Okay, so I at least want to show you this. This, in the past, and just a preference, this was usually the method I started with when we factored. The ax squared plus bx plus c. So, for what that's worth.
We're going to do factoring by groupings with 3, right?
So, let's try that. Let's go, yeah, we're going to do 3 terms. Now, 6x squared plus 13x plus 5. And this is where we go, oh, but wait, you said factor by groupings 4 terms. I did. We're going to make it into 4 terms. Now, if we went back to Tuesday, I told you to multiply first and last term. I'm still going to do that. Multiply to get 30. Add to get 13. Still the same thing. Now, what Berry method then does is it goes off and says, let's take the 6x and put them in the beginning. It'll clean up, and work out. This one follows a little more mathematical sense going through. So I want to add to 13. What two numbers do I want it to add to 13? 3 and 10. So I got 3 terms there. I want 4. So what if I could take a term and break it into 2?
6. You could do the 13 and do 3 and 10.
13x, we can make it into 3x and 10x. Does it matter the order? No, it doesn't. You can do 10x, 3x. So I'm going to break 13x into 3x and 10x. It's still the same process. Multiply first and last, find your product, pick the middle term, that's the sum. But now we take that, break it apart. Suddenly it's 4 terms. Factor by grouping. See what happens. If I factor with the first 2, what do I take out? 3x. Okay, leaves me with a 2x plus 1. We cross our fingers. Hopefully when we factor with the last 2, we have a 2x plus 1. Will we?
Yes.
What comes out?
5.
All right, so now I got 2x plus 1
Where did you get the? Oh.
and 3x plus 5. Factored by grouping. This we've done. So we take these trinomials that are a little guess and checky. You call it guess and checky? We're going to call it guess and checky. They're guess and checky. We still have to do this process, but then we break it apart, do factor by grouping. Why I like factor by grouping is it's the same process. We go through that process. It works out. We get to a result. 2x plus 1, 3x plus 5. Now, if we were overlooking in Berryland,
How did you get 3x?
the 3x and 10x, or right here?
Can we just not do Berry method? Because that's going to confuse me.
3x as like.
It's factored out of these 2 terms.
It's going to work way better for me. I can already tell. Because like Berry, I kept asking questions.
Mr. Davis,
Yeah.
should how this works. This is a lot easier.
Well, with Berry method,
Well, that gets you to come back.
it would just confuse me. With this, you can't ask questions about it. It just is. Don't ask questions. You get the same.
Oops. Okay, Berry method, we would have got the same result. Again, doesn't matter to me which method you use. I need you to be able to factor. All right, so let's focus on the factor by grouping. Okay, let's go on there. We'll put Berry off to the side.
Yeah, that makes way more sense.
Let's now look at how about 6x squared minus 7x minus 5. What am I multiplying to? 30 again, okay. But I'm going to add this time to be -7, -7. So positive product, but negative sum, it's going to be a, well, one of them needs to be, that one needs to be -30. There we go. -30, so negative product, negative sum, we're going to have a positive and a negative. Yeah, -10, 3. So we're going to take -7x, break it into 2 terms, turn it into factor by grouping, and factor out from there. Again, it doesn't matter if you went -10x and then 3x. Doesn't matter. Either one. Which one do you want to write first? -10. It says a lot about your personality. You're a pessimist because you start with a negative. You didn't know math problems had personality tests hidden in them? They do. From math tests, we also find out that you're odd. Like the numbers. All right, what comes out?
That was funny.
Now what? What comes factor out of the last 2? 1. Yeah, it's 1. It's good that we think 1 and we're not saying nothing because we don't want to forget that when all is said and done, there'll be a 1 there. But eventually the 3x minus 5 comes out. So 3x minus 5, 2x plus 1.
Wait, why do you have a plus 1 right there?
I don't have a common factor to come out, but I put the 1 there so when I do take this away, I'm not thinking it's 0 left over. So you agree that 3x minus 5 is in common, right?
Yeah.
Okay? If I take that out, it's not just going to be 2x, it's got to be 2x plus 1 because it's factored out.
Because you're not just completely taking it away.
Let's think blob. If it was 2x blob
Mary method was like,
plus blob, and we factored out a blob, it'd still be 2x plus 1. There's still something left over there. That's all.
and you just get rid of that and go down to 6 minus 10.
Okay, you're going to try 2 of them.
It's a solid. You wanna? It's solid. My brother, Mr. Davidson. You ever heard that song?
Hold on.
La Noche del Zorrito Picante. Oh. Have you heard that song? Huh?
You have to multiply it to each other.
Okay, I'm going to take 4x squared. I got negative 8x. What do I want to make that into? Negative 8. What do I want to split it to?
Negative 6, negative 2.
Yeah, negative 6x, negative 2x, because I have multiplied to 12, adds to negative 8. Put the 3 on the end. Take out a 2x. I got 2x minus 3. How am I going to make everything match for the last 2 terms? Take out a what? Yeah, negative 1 comes out, 2x minus 3. Pay attention to the negatives, especially when it's like really close. We got 2x and the 3, but the negatives are off. You got to make sure things go in the right place. So we got 2x minus 1, 2x minus 3.
Wait, I have it the opposite.
Same thing. It's multiplication. You can write in the other order.
Alright.
All right. Here I got 120 adds to negative 23. So they're both negative values. What are we going to go with? Okay, 8x and 15x. I'm going to take out a 2x. I got 3x minus 4. I'm going to take out what? Negative 5. We got 3x minus 4. Hey, we have a match. 3x minus 4. 2x minus 5.
How did you get 8x?
They add to negative 23, but they multiply to be 120.
It's only 20 though.
Multiply, it's 120. They have to add to negative 23.